All right, so let's now go back to the slides over here. And let's now talk about the design for the events. So we got actions, and also we got the guard. Why don't we talk about the actions first, which would be simpler to actually design, and then we talk about the guard. Okay. Right, let's go back here. So I got ILN over here. Right, let's focus on these events only, these new events. So we'll talk about the guard a little bit later. Let's talk about the actions, which are supposed to modify or change the concrete variables. But how should we change them? ILM simply means the car actually wants to go into the island, right? If you look at this diagram instead, yeah, it will be clearer, right? So if you actually got, let's say, a car over here going off the bridge and enter into the island, so this will be ILM. What variable should be changed? Apparently, C over here presumably should be 0, because that's the opposite traffic. We don't want any crash. So that means we have to change both A and B, right? How do we change them? Right? You can now pause the video and write down your answer. Assuming that you did, let's see what your answer, if your answer matches mine, right? So the action over here, as we can see very clearly from the diagram, it should be, since the car is moving from the bridge into the island, so the counter for the bridge traffic should be decremented. So that means A becomes A minus 1, and the counter for the island cars should be incremented, and B becomes B plus 1. Right? That's very straightforward. And let's now talk about the symmetric operation, the symmetric events, which will be IL out over here. Right? Let's talk about IL out as well. And what will be the action? What kind of a modification should we perform on the concrete variables? Let's visualize it. So that means now you want to have a car that's already in the island. They actually want to go back to the mainland, so they have to get onto the bridge. In that case, this will be the opposite direction, and that will be represented by island out. Right? So now you can now pause the video and tell me what concrete variables should be modified. You can now pause the video. Assuming that you did, you can see here when ILL actually occurs, presumably A should be 0, right? Because there should be no opposite traffic, otherwise we get a crash. So that means we should really change B and also C. How do we change them? Well, so B, since the car is leaving the island, so the island counter should be decremented. So B becomes B minus 1. And since the car gets onto the bridge and heading back to the mainland, so that means the C counter on the bridge should be incremented. C becomes C plus 1, right? You can see this part over here is symmetric to ILM. One is plus, the other one is minus. And the other one over here is, you can see one is reducing the traffic, the other one is increasing the traffic, but on the opposite direction. Right? It's very important to observe that as well. Straightforward, but how can you complete it correctly? It really depends on whether or not you understand about each variable, what each variable really means. Okay, beg your pardon. Alrighty, so let's now talk about the guards, which will be very important. Let's now see some description for the guard, right? ILN, let's talk about it first. Entering the island. We should be able to enter the island, a car should be able to enter the island if the bridge's current traffic flows to the island. Well, what does that really mean? Okay, you can note down this particular condition over here, right? So that means if I want to take this direction over here, that means the opposite direction of the traffic for the bridge should not be the case. Otherwise, we got crash. How do you encode this safety constraint into the guard? How do we do that? All right, so this is going to be something you got to fill in. All right. You can now pause the video and write it down. All right, assuming that you did, that should be straightforward, right? So that would mean in order for A over here to be flowing, right? So that means the opposite direction should be empty, right? So that means C equals 0. And that's it. Here is my question for you, right? You might be wondering, oh, really? that's strong enough guard, shouldn't we also worry about if somehow this if a car actually goes into the island, don't we have to make sure adding this car into B? Remember, we actually got some constraint earlier, right? If you think about the abstract model, if you remember the abstract model, right? Let me put it here. If you remember the abstract model where we got the island bridge compound, right? That's the island bridge compound. And this part over here is the mainland, right? That's our initial abstraction, right? M0 abstraction. I don't need to refer to the original diagram. I want to put it here. And remember, there's only one variable there, which is n. We say that the total number of cards in the island bridge compound n should be less than or equal to d, right? That's what we said earlier. Just remember this constraint. But now, when we actually try to say that have one occurrence of ILN, in that case, shouldn't we actually check to see this card over here entering the island is not going to, for example, if B over here is already equal to D. Let's say that's the case. In that case, adding this card into the island is going to make it D plus 1, which is going to violate this abstract invariant, which is bad, right? Let me write it down, and then I'm also going to post the question on the slides, and then we should talk about it, right? So let's say over here, let's say B, right? Let's say we try to do ILN, but let's say B is already equal to D, which will violate the corresponding abstract invariance, which is the n less than or equal to D, right? This is my question to you. It's a very important design issue you want to think it through before we can actually move on, right? And let me also try to phrase the question in a different way on the slides over here. We actually said the number of cars on the bridge and the island bridge compound should be limited, but somehow our guard for ILN is not really covering that. Do we have to? You can now pause the video and think about your arguments. Alrighty, so hopefully you thought about it. I would say this is really the only tricky design issue we have to get through among the two new events. I think that's really important. That's why I want to spend some time with you over here. All right, so the answer is we don't actually need to specify this extra guard, which will make sure the total number of cars on the bridge and the island, which in this case will be, basically we are really asking, should we really need to say A plus B over here is less than or equal to, should be strictly less than D, right? This is really something we are asking ourselves, whether we should do it, right? We want to make sure before we actually increment the counter for this B over here, we want to make sure A plus B over here should be strictly less than D. So when we plus 1 into B, in that case, it's actually going to, still maintain a counter, right? Do we need that? Well, the answer is no. Two reasons over here. One is, you can see over here, when we talk about the sum of A plus B, right? You can see from the action, one is decrementing, the other one is incrementing. So when we actually say A plus B, we're going to get A minus, think about A prime plus B prime in the post states. It's going to be A minus 1 plus B plus 1. It's still going to be A plus B, right? It's a very important thing for you to actually observe, okay? Okay, so from here, we know that A prime plus B prime, before after predicate, right? In the post states, it will be A minus 1 plus B plus 1, which will be equal to exactly A plus B. So the total number for A plus B remain the same. That's observation number 1. So that means you don't really have to make sure A plus B is less than D. You don't have to. That's reason number 1. Number 2 is exactly what I remarked just a few minutes earlier. In order for this car to really get to the island, the counter check was already done when the corresponding ML out actually occur. right? So if you actually think about what's happening over here, right? Let me just move back to one of the guard over here. Let me just find it. If we go to ML out, right? You can see for ML out over here, we actually got A plus B less than D. That's exactly the guard which we're wondering if we should also put it in the ILM. But it turns out we don't need to, because when the same car actually wanted to leave the mainland and get onto the bridge, we already make sure this actually was the case, right? And then later, when we actually the same car actually want to get off the bridge and enters the island, so that'll be denoted by the ILM. In that case, this constraint will remain the same, and also A minus 1 and B plus 1 altogether will be just A plus B. So this constraint will not be violated, right? So these are the two things you want to think through. Right? Let me go back. I'll write it down, and then you can think about these two things. Okay, so this will be unnecessary. Okay, actually, I think I can use purple. That's fine. Unnecessary. Unnecessary. Unnecessary because number 1 over here, and also number 2, the ML out earlier for the same car already checks it. It's a very subtle design issue that is not really mentioned in the textbook, but I think that you deserve to know about the rationale behind. All right? Right, so just make sure you will know how to answer any assessment question. If I simply ask you about whether or not this guard here is really logically necessary, the answer is no, because of these two reasons I just went over with you. All right, let's now go back over here. Right, you know what? Just to make sure it's actually part of it. So why don't I just make this part over here also red? Right, so you can see they are actually related to each other. Okay, good. Let's now go back. And what about the IO out, right? The opposite event. That one should be quite straightforward, but we still need to do it, right? We already talked about the action part for IO out being this one over here, right? Which is good. And what about the guard? The IO out events is going to be enabled only when there is some car on the island, basically, right? Well, basically, this one is saying that in order for some car to actually go exit from the island, you want to make sure there's at least one car in the B, right? When we say n less than or equal to d, that's only about the upper bound for the number of cars, but there should be some lower bound as well. In order for a car to really exit from here to here, we want to make sure this number here is at least 1, right? That's something we want to make sure. So this one should be easy. You don't need to pause the video. I'll just tell you right away. This one over here, but of course you should really know, given the informal description for what a guard when the guard should be when the event should be enabled, you should be able to formulate the guard using predicates, right? So this one here should be simply be larger than 0. All right. So that's all you need. Of course, there's another one which is also always needed. You want to make sure the traffic wouldn't really cause any crash, right? Since we are actually going from here to here, in that case, we want to make sure the opposite side is actually 0, right? So that will be A equals 0. So these are the two constraints over here. All right. Let me recap very quickly before I end the current video. So we basically talk about the design for the guards and also the actions for the two new events. You should also know about the distinction between concrete events versus concrete and new events, right? And also understand about why this particular logical constraint is not really necessary for the guard for IOM because of the two reasons I mentioned earlier. All right. All right, let's now go back here and let's now move on to the next part about before-after predicates.